All right, this problem is talking about the amount of carbon in a dead thing remaining and using it as a way to determine age. So I've set up the two equations that you would need to solve, and notice that we never actually need to know the initial amount of carbon that existed from these two equations. So if I want 10% of the original amount left, then that means I want 0.1 of the original amount equal to my right-hand side. Make sure you include your negative and your correct amount of zeros. But now notice that that original amount of carbon is just going to cancel out. So when I'm solving this, I'm going to take the ln of both sides, or I'm just going to use the solve feature on my calculator. So let's go ahead and do it. I've got solve 0.1 equals my e to the x button, negative 0.000124t. Let's put in a times t just to make sure that my calculator is doing what I want it to do, and I want to solve for t. And I get that the age is really, really old, 18,569.2 years. And because I'm doing an estimate of time, I can go ahead and say that I've got those 0.2 years because it doesn't ask me to the nearest year. So my time is 18,569.2 years. All right, how long will it take for a half-life? So I want half of my carbon remaining. Same idea, except this time, instead of 0.1, I'm going to solve for 0.5. So I'll go ahead and change that out. All right, and it takes less time. So in this case, I could say 5,589.9 years. Or I could round that to 5,890 years. At that point, I'll have less than half. If I had said, so just less than half. If we had said 5,889 years, then I would have just over half. So it depends on how your question is worded to know whether you're going to round up or round down, but those are things we need to think about. In this case, I would stick with our exact answer though.